Imagine this. A virus enters your body. Your immune system fights it. And finally you recover. End of story, right? But not with herpes. Herpes virus does something almost science fiction-like. It hides inside your nervous system, goes silent for years, and then suddenly wakes up. More than half of all humans carry this virus, and most of them don't even know it. So what is herpes really? How does it infect the body? And why is it so hard to cure? To understand that, we need to follow a virus on its journey into your nerves. Herpes isn't just one virus. It's a family of viruses, but two types infect humans most often. HSV-1, commonly oral herpes, cold sores. HSV-2, more commonly genital herpes. But here's the surprising truth. Either virus can infect the mouth, genitals, eyes, or fingers. They spread through direct skin-to-skin contact with microscopic breaks in the skin, or mucous membranes. And once herpes enters your body, it doesn't just infect cells, it rewrites the rules of infection. When herpes enters the skin or mouth, it invades surface cells and starts replicating. These infected cells burst, forming fluid-filled blisters, the classic cold sores or lesions. For some people, the first infection feels like fever, muscle aches, headaches, painful sores. But for many others, there are no symptoms at all. And that's where herpes becomes dangerous in a different way, because the virus is already moving deeper. Most viruses stay in the bloodstream or tissues. Herpes does something unique. It travels into your nerve cells. Inside nerves, it moves along long fibers called axons, like a train traveling on tracks. Eventually, it reaches clusters of nerve cells called ganglia. HSV-1 usually hides in the trigeminal ganglia near the brain. HSV-2 usually hides in the sacral ganglia near the spinal cord. And then, it goes silent. No symptoms, no replication. Almost invisible to your immune system. This is called viral latency. Now the question arises, why herpes comes back? Herpes never leaves your body. It waits. Stress, illness, fatigue, sunlight, or hormonal changes can wake it up. When reactivated, the virus travels back down the nerve to the skin, causing tingling, itching, burning, blisters or sores. This can happen monthly, yearly, or only once every few years, and sometimes you can spread the virus without symptoms at all. Herpes is extremely common. Over 50% of adults worldwide carry HSV-1. Hundreds of millions carry HSV-2. Up to 90% of infected people don't know they have it. This is why herpes spreads silently. It's not rare. It's not exotic. It's one of the most successful viruses on Earth. Most important point is how herpes is treated. There is no cure yet, but there are treatments. Antiviral drugs like acyclovir, valacyclovir, famciclovir. These drugs don't kill the virus. Instead, they block viral DNA replication, shorten outbreaks, reduce pain, lower transmission risk by about 50%. Over time, many people experience fewer outbreaks as their immune system adapts. Why herpes is so hard to cure? Most viruses can be eliminated because they stay active. Herpes hides inside neurons, cells that the immune system avoids damaging. Killing infected nerve cells would mean damaging the nervous system. So the immune system makes a trade-off. That means it controls the virus, but don't destroy the nerves. That's why herpes can last a lifetime. As far as future cures are concerned, scientists are exploring CRISPR gene editing to remove viral DNA, therapeutic vaccines to reduce outbreaks, and preventive vaccines to stop infection entirely. Early studies show promise, but a universal cure doesn't exist yet. Here we can conclude that herpes isn't just a virus. It's a master of stealth, biology, and survival. It hides in your nerves, sleeps for years, and wakes up when your body is vulnerable. But understanding it removes fear. Knowledge turns stigma into science, and science into control. If this sparked your curiosity, you're already one of us. Because knowledge grows when it's shared. This is Illuminate Science, where curiosity turns into clarity.